You'd think we've got a pretty good handle on our own solar system. But one of our biggest neighbors is hiding a secret that pretty much breaks all the rules. We're talking about Jupiter, the gas giant, and it's impossibly hot. So today, we're going to dive into two radically different theories that try to explain why. So here's the central mystery. Jupiter is radiating way more heat than it should. I mean, think about it. It's so far from the sun, it should be a total ice ball. But instead, it's scorching. Our models just can't make sense of it. So what's really going on here? Get this. Jupiter's upper atmosphere is clocking in at a staggering 700 degrees Celsius on average. To put that in perspective, that's hot enough to melt lead. And this is on a planet that gets only 4% of the sunlight we do here on Earth. It just doesn't add up.
And this is where it gets really wild. This is just how big the problem is. Okay, so based on sunlight alone, our models predicted its atmosphere should be a super chilly -70 degrees Celsius. But what do we actually see? Temperatures soaring up to 1,000 degrees. I mean, we're not just off by a little bit here. Our understanding is completely, fundamentally wrong.
Okay, so where in the world could all this heat be coming from? Well, the leading mainstream theory points to something you've probably seen amazing pictures of, the planet's absolutely spectacular light shows. The basic idea is that Jupiter is being heated by its own incredibly powerful auroras, essentially turning its poles into a planetary furnace.
So here's how they think it works. First, you've got the heat source, Jupiter's massive permanent auroras. Then, the theory goes, these super powerful global winds act like a kind of planetary circulatory system. They literally pump that intense heat from the poles down towards the equator, spreading it all around. And what triggers these insane auroras? A couple things. Its interactions with its volcanic moon Io, and of course, the solar wind.
But, okay, here's the catch. While this is the leading theory, the sources are pretty clear that we're still missing a solid, undisputed mechanism for how this all actually works. And if you dig into the technical diagrams, you find this really interesting phrase, magnetic reconnection. Tuck that phrase away because, believe me, it's going to come back in a big way.
But what if the answer isn't some super complicated weather system at all? The source material we looked at presents a completely different explanation, one that forces us to shift our entire focus from the force we all know and love, gravity, to something else. And right here, this is the fundamental split. You see, pretty much all of our mainstream models of the cosmos are built on gravity. It's the star of the show. But this alternative theory, it proposes that the universe is actually run by a different force, charge. And look, if that's true, the physics of charge could be the key to unlocking not just Jupiter's heat, but a whole lot more.
So remember that phrase I told you to tuck away, magnetic reconnection? Well, in this new model, it's not just a footnote, it's everything. The author even calls it something a bit more intuitive, photon spin friction. I want you to imagine two powerful rivers, but instead of water, they're made of charge, and they're flowing in opposite directions. When they slam into each other head-on, it violently unleashes their energy as intense heat and magnetism.
Okay, so let's walk through how this supposedly works on Jupiter. Step 1, you've got an incoming stream of charge from the solar system, and it meets another stream that's flowing through the planet itself. Step 2, these two opposing streams collide, head to head. Now here's the crucial part. Instead of just canceling each other out, their opposing photon spins actually combine. This creates what the author calls a spin-up, which just massively increases their energy. And the result? Intense heat and magnetism generated right there at the poles where that collision is the absolute strongest.
You know, a really good scientific theory doesn't just solve one little problem and call it a day, right? The author argues that the real power of this charge-based model is its ability to explain all these other bizarre, seemingly unrelated mysteries all across our solar system, using the exact same mechanism. Okay, let's take Neptune, for example. For 15 years, scientists were scratching their heads because Neptune was actually cooling down during its southern summer. Makes no sense, right? And then, all of a sudden, its south poles started heating up fast. Well, according to this theory, that isn't random at all. The author claims it lines up perfectly with their model, linking that sudden warming to a big surge of charge from a planetary alignment with, you guessed it, Jupiter. And it doesn't stop there. Then you've got Uranus. It's blasting out X-rays, and honestly, we're not totally sure why. The mainstream theories have these huge gaps, leaving another major planetary puzzle just sitting there, unsolved.
Look, the mainstream explanations just don't seem to fit all the data we're seeing. So, one idea is that the rings are the source, but that only explains the X-rays at the equator. Another theory points to the auroras, but that only works for the poles. But this charge theory, it claims that photon spin-up can happen basically anywhere the planet's charge field interacts with the sun's. So that could potentially explain the emissions we're seeing from, well, from all over the planet.
But okay, the author doesn't just stop with the planets in our backyard. No, they propose the ultimate test for this whole idea, seeing if it can explain quasars. You know, just the brightest and most powerful objects in the entire universe. All right, so the standard gravity-based explanation for quasars goes something like this. When two galaxies start to merge, gravity, and I'm quoting here, funnels material into their respective black holes, igniting their quasars. So the idea is, all this stuff gets super hot and glows like crazy as it's getting sucked in. But the author of this charge theory asks a pretty simple and, yeah, pretty provocative question. They say, look at the actual photos of these merging galaxies and ask yourself, do you see any funnels? I mean, if this whole gravitational feeding frenzy was happening, shouldn't we see these bright, clear streams of stuff being pulled in? The author's point is, we just don't. So what's the alternative? Well, it's that this incredible brightness has nothing to do with stuff falling into a black hole. Instead, it's the exact same photon friction idea we talked about with Jupiter, just blown up to a galactic scale. You have these two massive charge fields from the galaxies, they collide, they spin up, and they release an absolutely unimaginable amount of energy as light. So as you can see, we've gone way beyond just talking about Jupiter's temperature. What we're looking at here are two totally different ways of seeing the entire universe. It really questions the fundamental forces we think are running the show. All right, let's just break it down one last time, side by side. So in the mainstream corner, you've got a universe run by gravity. Jupiter's heat comes from its auroras, and quasars are powered by black holes. Simple enough. But in the challenger's corner, charge is king, and both Jupiter's crazy heat and the power of quasars come from the very same thing, this idea of photon friction. And all of this leaves us with one final, really massive question. I mean, think about it. We started this whole thing with one hot planet in our own solar system, and we ended up with colliding galaxies at the edge of the universe. It really makes you wonder, have we been missing a huge piece of the cosmic puzzle this whole time? Could it be that charge is the hidden, unappreciated engine that's actually driving the most powerful events in our cosmos?